Welcome, everybody. We're here with another episode of Infinite Layers. Today, we're joined by Witness Chain, and I'm going to go ahead and ask the guests, Ranveer and Pramod, to please introduce themselves and give us a quick overview of what Witness Chain is.
Thank you for having us here. Hi, everyone. I'm Ranveer. I'm the co-founder CEO of Witness Chain. At Witness Chain, what we are building is a coordination layer to unify DePIN economies. A little bit about myself. We started Witness Chain around 3 years ago. Before that, I did my PhD in solving the blockchain trilemma. I was co-advised by Pramod and Shriram. And towards the end of my PhD, we started this project with Pramod.
Hi, Nader and Gajesh. Thanks for having us here. And my name is Pramod. I'm a professor at Princeton University. Before that, and I've been working in blockchain for some time, but my biggest achievements are that I introduced blockchains to Shriram. When all the dust settles down, or maybe it's already settled down, that's been my biggest claim to any achievement in blockchains.
That's a really cool intro and a really cool story. I would love for you guys to maybe touch on that a little bit more. How did you all meet each other, and I guess what was the story there in terms of?
Well, I think Shriram and I go back almost 15 years ago. So he was my PhD student, and we've been, I'm a very accessible professor, so we work together very closely, continuing to work actually and regularly interact. And sometime in 2017 December, I remember I think maybe he had some time off, his wife was traveling, so Shriram came to my house. He stayed for about 10 days, Christmas break 2017. He was doing some RNA sequencing or single cell sequencing. I'm not exactly I don't even know what those things are, but I was telling him about Nakamoto and blockchain. And around 2018, February, March, he joined, said, all right, I'm all into blockchains. Let's start working on it. At that time, we were just trying to understand blockchains we are networking people. We love networks. One of my very first startups in my PhD out of Berkeley was in networks. We were doing wireless networks. Wireless networks were for like phones. You make phone calls, and internet was happening in late 90s, early 2000s. So we were thinking about how to build wireless networks, data native. Every bit wireless was our tag list. And imagine you could do email on your phone was our sort of pitch deck. And we're building technology that is sort of internet native, but also has wireless. It sounds like a kiddish thing now, but this was cutting edge, and it became 4G LTE. So it's a success story. That's also my first experience building networks that scale globally. Man, woman, child. And of course, that got built. So Shriram ended up doing his PhD was also around this topic, trying to scale even more and basically make it really, really data focused and optimize the networks to be significantly. Basically, it's like a blockchain. You need to be robust and yet be optimized. So this is the grand challenge in all of these networks, Nader and Gajesh, is that you want to optimize. Obviously, you want to do well. Everybody wants good performance on their phone. But if you try to optimize for one person, it becomes brittle, and the whole network, global scale, breaks down. And so this is what we've been doing. But we were kind of bored of that at some point, and I was doing some AI, and Shriram was doing this single biology thing. I can't even say what those things are. When we saw blockchains, I had another student at the time. She's a professor at Carnegie Mellon now, so she introduced me to blockchains, we felt this is a calling. We build large-scale networks that align a whole bunch of complicated systems. At the same time, optimal and optimized and efficient. We loved working on blockchains. It's like a natural fit, like native swimming. We were new to this, but we did a lot of work. So it was good fun. That startup didn't go very well. We got washed out in that bear market, but we learned a lot of things.
Yeah, it sounds like a lot of the work that you all had done kind of set the stage for diving into this space and having fundamental understandings of different areas that might not be so straightforward for people that had just maybe just dived in out of like not having worked in any other domains before, maybe?
Yeah, I mean, it came in naturally. I think there is, in wireless, every leaf of every tree, these are radio signals. Every leaf of every tree bounces the radio waves. And so you can't be like very, very hung up. I mean, you need to be robust. Here in blockchain, anybody can do anything and they have plausible deniability. So you need some robustness. And they're really at the end, blockchain is a network. And wireless are networks too. So it's native, it's good stuff.
So for Witness Chain specifically, can you kind of talk about how it came to be? Is this something that you all had been thinking about and then it kind of turned into this product? And what exactly can developers do with Witness Chain, like ultimately or even now?
Yeah, already. I mean, Witness, like Ranveer was saying, it's a few years project. We started at the same time. I mean, we're sister startups with Tigan and Witness. I mean, Sriram is actually a co-founder at Witness, as an advisor. I'm an advisor to Eigenlayer. So we are birthed at the same time. We're twin projects that way. And our tech was, we took a different, I mean, what we did is basically I started thinking about something that one of the things that I thought blockchains can really solve, a real use case, is that where things are actually decentralized already and physical infrastructure is actually decentralized. I mean, people are everywhere. Humans are all over the globe. So decentralization is like physical, like center, physically you're already in different places. So there's some natural decentralization. And but many of the infrastructure projects are very centralized, like governments run public utilities sometimes. And because of the capex, and also significant opex, you have very monopolistic, to the extent it's not a government, you end up having very monopolistic companies. So I mentioned this startup I started in Flareon. I mean, we did Flareon back in 2000. At that time, there were 15 carriers in the US. It's hard to believe, but today there's just Verizon and AT&T and T-Mobile. So basically that's it. It's an extraordinary consolidation because of the network, the monopolistic effects. And I still think very much that this is a killer app for blockchains in the sense that decentralization is actually there and you want to grow the network organically. The real problem is this chicken and egg. If you build a network, of course, people will come. But to build it, like I'll give an example, Verizon spent to roll out 5G nationwide, $15 billion. I mean, that's a large sum of capex just like that to roll a technology for which, it's not clear how much value you'll get back out of it. Can only do because they have kind of monopolistic view. And of course, they'll, because they're monopoly, they also offer, like, I don't know how much I pay. I mean, basically, I accept whatever they pay. It's like, I have no choice, really. I mean, I can go to AT&T and I don't know, anybody says they love AT&T. It's like 1-800-CALL-ATT is like a root canal or something. So it's not like anybody says, I love my carrier. There's a reason. And I don't blame them also because the way their CapEx works, the incentives are messed up. So I saw Helium, which was a project at the time.
Right.
And I like the thesis that you grow the network organically and the winds are blowing correctly. I mean, I follow wireless closely. The winds were blowing in the sense that you can have hardware is very cheap. Base stations used to be tens and even hundreds of thousands of dollars 25 years ago. Today, it's just a couple of $100, like a beefed up Wi-Fi box. All the networking compute stack went on the cloud, completely commoditized. And the last piece is spectrum. And spectrum also opened up about 50 megahertz, CBRS, Navy spectrum, opened up for lightly regulated commercial use. Because of these tailwinds, I still think this is a great time. It's just a slow business because you have to move the elephant. And that's how we started Witness Chain. To do the tech, which takes 5G or 4G networks, but natively redo the stack so that it's decentralized. So first principles view, blockchains are built for digital things, but these are physical or networking aspects, and people have to agree who did what. So that's how that's what we do. So we Witness Chain, we allow physical infrastructure projects to come out of their CapEx, OpEx, community building silos to be able to natively share whatever they did. It's like I call this sort of the network meritocracy. If you did good surveys because you put a base station where there was no coverage, then you as an individual should get rewarded. Like this is the equivalent of a miner. But you need proofs that you actually did that. And the traditional proofs in blockchain are that you're on chain. I mean, it's a ledger. But these are like off-chain activities, also physical activities.
Intersubjective.
And intersubjective, I love it. That's right. And this is actually a classic textbook example. We were discussing with Shobik the other day. This is a textbook example of where intersubjective of state can be found consensus at a network level. And what eigenlayer provides is consensus and alignment at the economic level. So the two kind of naturally match.
I would love to dive more into like how this works. But before we do that, let's dive into the presentation because I think that's going to explain a lot of it. And then whatever questions that are not answered at that point, me and Gajesh will start firing off, if that's okay with you all.
It's perfect. And if you want to embarrass anyone with more stories, I can do it too.
Feel free to keep those coming too. Okay, there we go.
Perfect. So I think Pramod covered a lot of the inspiration behind developing Witness Chain. Just to summarize it here, the physical infrastructure, due to its decentralized nature, fits the ethos of decentralization that already exists in the blockchain community, and that's why that offers an alternate and probably more economically viable way to set up infrastructure. And we have seen a few examples of this setup already. We give example of Helium, Filecoin. Those are what people typically refer to as OG DePINs. But one thing we see there is these DePINs themselves are siloed. And because of that siloed nature, they don't interact with one another. Moreover, they don't interact with any builders and applications sitting outside their ecosystem. This kind of siloed nature reminds me of tokens before blockchains. So Bitcoin is a token, but tokens existed even before Bitcoin. They're called airline miles or credit card points. The real value unlock that blockchains enabled was that now these tokens can be trusted by anyone, and third parties can develop applications on top of them in a purely permissionless manner. That led to a whole market discovery of where you can use tokens, and that's what enabled this $3 trillion economy that we see right now. And we want to enable the same thing. What's critical to enable this is some form of coordination. Right? I drew an analogy with traditional blockchains. Ethereum is what enables smart contracts to coordinate and add value to each other. A very recent example, as everyone would know in this community, is Eigenlayer, which enabled services which are not just smart contracts, actively validated services, to coordinate with one another and add more value. We want to develop something similar for the physical world. It does not exist right now. This is something that can enable this coordination. So what does coordination mean? What value does it bring? So let me discuss a few use cases here. So think of a futures market for a smart physical commodity like bandwidth. So if you have a futures market, this is an example of what we call DePIN DeFi. You can enable decentralized finance on top of physical assets themselves, right? You can compare Uniswap to a stock exchange, but what doesn't exist right now is a commodities exchange for smart physical assets. So somebody can develop that. And then somebody can develop an app, which is an equivalent to Twilio, to get bandwidth futures and get guaranteed bandwidth and resell it. This is a whole new kind of economy that can be set up if you have trust within these three entities. Similarly, why can't you use your physical assets as a collateral to get more loans? In traditional infrastructure, you can use your existing deployed infrastructure to borrow more money and deploy more infrastructure. DePINs cannot do that. It's because there doesn't exist trust whether that asset exists or not. If you can do that, like in this example, some Helium, a person who has a Helium miner can use that miner as a collateral to get new to diversify its DePIN portfolio. As an example, somebody wants to build an AI distribution dApp. An AI pipeline requires utilizing multiple DePINs. You can easily set that up if those DePINs can now coordinate, not just at a physical level, but also on a trust level. And you can build a lot more applications like that. Right? Now, what's required for this whole economy to bootstrap? And just like what was required in the case of blockchains was this consensus on digital state, so that everybody can build applications on top of the digital state. You require consensus on physical state. So any physical asset will have attributes such as where is it located, what's its connectivity, is it performing compute, and so on. And this requires identifying and solving those foundational scientific challenges. And that's what we have done here at WitnessChain. Maybe Pramod can expand, go into details of each of these systems.
Yeah, does it make sense, Nader and Gajesh? When we talk about agreement on something physical, the most basic thing is where are you? Like, where's Waldo? And that's like the most basic part of something physical, like location. And surprisingly, already a hard problem because if you're on the network, there's a famous New Yorker video. Anybody can on the internet, no one knows you're a dog, and the vice versa is also true. And people can use VPNs. I mean, it's like, how do you know where anyone is? And you may not. And of course, in Web 2 world with cookies, people will nail you down all the way to a meter, maybe near a mall or something, because they would like to give you advertisements targeted. So that is like the opposite extreme, where they really, really know you and they completely own your network, own your device, put cookies. I mean, you have no control over anything. Crypto is the other end, where anything can be anywhere. But in many of the applications, especially in physical infrastructure, you want to know where it is, then you can get rewarded. Also, it should be there. Otherwise, you get into all kinds of trouble. I mean, Helium can give many examples where there are some in the Pacific Ocean, and of course they're not there. But there's no way to. You're not going to go to the Pacific Ocean to go check. So you really need some way of saying where someone is, and it doesn't have to be like I said, down to your city and down to your street. Like an approximate, reasonable neighborhood is plenty good, and people need to agree that that's where you are. And ideally, it should be done just with the internet. If you can, one way to do it is through wireless. If somebody is nearby, they can hear you, like actually hear you. But that requires lot of people everywhere. Otherwise, if somebody is in a new place, then how will you ever prove yourself you're there? So we want to do it as much as possible just by connecting it to the internet and say where you are. And despite using VPNs, approximately we find you. One thing that you have that's what we call proof of location. At the end, proof of location is still triangulation. I mean, you put circles and see where the intersection is. There's nothing going on. The geometry has not changed. But what has changed is that some people will lie. Or some people will use VPNs to lie. And you still need to figure out, it's like back to the high school days, everybody struggles through high school through do trigonometry. Gajesh here skipped it, so he may he may not have gone through that hazing, but most of us didn't have that privilege. So we had to do geometry. And starting from the ancient Greeks, I mean, you have given some angles, given some lines, you want to find something else. But this time somebody's doing some messing around, somebody's lying. Euclidean geometry is still geometry. So we did what we call adversarial trigonometry, where some things are outright lies, but you want to catch them because they're not meeting the laws of geometry. And once we're able to do that, we can now give you a proof of location on chain. And the way to do it is through just the internet. You're connected to the internet. If you use VPNs, the idea is that the fact is, if you're using VPN, you still have to go. I mean, the key is that we want to bring crypto primitives inside networking protocols. Typically, networking protocols like ping. Ping is actually common enough that it's used even in non-networking. People will say, let me ping you.
Mm-hmm.
Ping is actually a networking protocol between two IP nodes. But what happens if the other side doesn't follow ping? So this kind of question had never been answered until we came along and we started putting crypto primitives, most importantly signatures, and the fact that you received packets and hash functions and hashes of packets inside, to build sort of networking libraries with the crypto primitives inbuilt. So that's in some sense our core tech. So there's a whole area, technical area, actually deep tech. People call this rocket science because it's actually rockets fly because of wireless. And but they never had to worry about the other side not following protocol. They didn't think about it at all. And so one of our core tech is, and this is our deep tech, is to redo these primitives with crypto guarantees.
So how would the proof of location be used in like a use case that might translate to something that exists today? And then I don't mean to block you on the rest of the presentation.
No,
so you
it's
can
a
continue
perfect question. Ranveer, do you want to say this?
Sure. So, one of the motivations for this was to, even outside DePINs, is to prove decentralization for Ethereum or, any decentralized networks.
That's a good one.
That's something a lot of people can.
That's a very good one, actually.
So the thing is, like, once you start, okay, so let's say there's a network and they want to incentivize decentralization. Now, this is very important for DePINs, where decentralization literally means coverage. But even for protocols like blockchains, where they want to incentivize decentralization, the moment they start incentivizing it, people start gaming it. They can lie about their location. So you could have gone and said, hey, like, deploy some GPS module or something at your validator. But that's something very easy to lie. So in order to enable these kind of incentives, or just to show that, okay, like, you are decentralized to begin with, you need a Byzantine fault-proof method to determine location. And that was, in some sense, the genesis of proof of location. The use cases in DePINs are obvious. If somebody wants to deploy a wireless network, somebody wants to deploy an energy grid, or CDNs, compute, and so on, they want servers close to where the use cases are, and the use cases are global, so they want servers everywhere. And over there, they obviously need to prove where the systems are located.
Very helpful.
Wait.
Yeah, this was like where you are, and once you kind of say approximately where you are. For example, our current POLOC is live on our networks. We can talk about what we are talking about, the very deep tech itself, but actually Witness Chain is a network. The same people and the same operators who run EigenLayer operators are all Witness Chain, most of them are also Witness Chain operators. These proofs are done and enabled by these operators. And all our rewards and our sort of business, we can talk about it, will flow to these operators.
So in some sense, your operators are an equivalent to GPS satellites. So we call them watchtowers. In a triangulation analogy, that's an equivalence that you can draw. So it's in some sense allowing the set of servers which were previously Ethereum validators to also validate locations for DePINs. Inherently, DePINs have been some DePINs have tried this, and over there they try to determine the location through their own intrinsic set of validators, and also tie themselves to the local geography, which leads to very high collusion. This kind of proofs enable the global set of operators to validate DePINs, which is a new bridge in some sense that we have created between these two spaces.
Yeah, EigenLayer aligned a whole bunch of operators. Operators come in naturally because they're called miners in blockchains, but EigenLayer allowed them to be broader and restake whatever they were doing to provide other services. And what we are further generalizing is that once this alignment has happened, economic alignment has happened, It's a very lightweight container. We'll give you a very lightweight container. In fact, Pollock can even be done challenged from a phone. So it's such a lightweight need from a hardware perspective on the operators. So it's like a no-brainer. They're already doing all this. They might as well do a little bit more and get even more rewards. The hard work is actually building this network. I think I alluded to this. That's why like Verizon would spend 15 billion to roll out a network.
Right.
But once you have the network sort of organically running, economically aligned, then these kind of services that previously unimaginable just starts economically very hard. I mean, conceptually cleaner.
Yeah, and I guess like one thing that I'm just assuming is that like if you wanted to compete with Verizon or one of these networks, it would be so hard or impossible almost, because you literally have to build everything from scratch yourself. But with a network like this, you could potentially incentivize people from around the world to participate to help bootstrap it through crypto economic incentives. Is that the idea?
That's one idea, but I want to just say a little bit more color on that, Nader. That's correct. But people will say, how can I ever get out of my phone? I need connectivity, which is true. But the phone is just all you can eat stupid service. Really, networking is the third tripod of two other components that drive the information age. There is storage. You need to put your data somewhere. You need to compute, which is execution. And you need to send it around, networking. Storage became commoditized, Dropbox. Compute became commoditized, AWS and Azure. Networking still in the dinosaur era. They become even more dinosaurized. And because of this, but the connectivity is so important that you can't get rid of them. So it's not so much compete with them as much as offer something that they simply don't. I'll give you one example. Suppose you want 1 GB of data every night between midnight and 4 a.m., all Bay Area zip codes, 250,000 devices. This could be Tesla's contract, fictitious contract with, let's say, AT&T. They have no such contract. I mean, and they with all their leverage. So there's a whole bunch of startups looking for just connectivity. And they don't want all-you-can-eat kind of service. I mean, they want service, then they're willing to be in the middle of the night and only sometime upgrade the car, upgrade your dashboard. Dashboard companies would like to just offload all their data, and all these AI companies that are sensor related, computer vision or messaging, they all want to go back to the cloud to run their large machine learning models and come back. And each one of them has very specific networking needs. And the siloed version of business calls, I mean, like that's why I said 1-800 call ATT is like a root canal. I mean, there is no BD for this kind of activity. Whereas there is such an activity for AWS. You can get what you can log in on AWS. You can say, I want this many virtual machines, this many GPUs, some of them spot, some of them all the time, this much storage, just a couple of buttons, boom, you have your virtual, compute needs ready. Why can't you have the same thing for networking? You can enable this contract I said. So really not so much dislodge these dinosaurs as much as enable efficiencies and on demand for a whole era of small businesses that are coming with AI.
Makes sense.
This is what I mean by like a real use case, in the sense that these things are not maybe they're slower moving because their entire in like a big part of the information world itself changing, but the forces are there, the tailwinds are there from just the wireless and hardware and spectrum side, and the need is there, demand is there from the AI side, and AR VR perhaps coming too. And the need to basically do a lot of things on the cloud, and networking should be nimble and aligned with it. So this was how we started Witness. It's slow moving. We acknowledge it. It's a real impact, but slow moving.
Yeah, I mean, it's a massive undertaking for sure. Question: if someone wanted to start leveraging this once the specific use case or I guess product within Witness Chain was ready to use, for instance, proof of bandwidth, would they interact with like a node on the network, or would they be running the software themselves, or like what would that integration, I guess, look like for someone building something that wanted to utilize this?
That's a great question here. So let me just give you pull a diagram here. So the way the system works at a high level is, DePINs register with us. What this registration means is that their assets, be it radio, storage, whatever the physical asset is, gets registered on our chain. Now, those assets are now open for eigenlayer operators, the watchtowers, to validate. Now, eigenlayer operators are going to run software modules, very lightweight software modules. In fact, Pramod said that this is something that can run on a phone itself, called challengers. And they will make sure that whatever properties this asset claimed is correct. Now, the commitments, the certificates for those properties will then get submitted into the DePIN coordination layer. And then that makes those assets validated assets. And that opens up a whole variety of applications to be built on top of that. It's a high-level overview. If you want to, I might go into a bit more detail.
Yeah, that
here.
makes a lot of sense. Yeah, I like that. It actually crystal clear now versus what I was trying to come up with in my own head.
Yeah, so what's important is that most of these proofs are like very lightweight software containers. Doesn't require any specialized hardware to deploy, and that's why it's so easy for any operator to like use our piece of code. In fact, they actually have an option. So the way DePIN coordination layer works is you have like one great thing about consensus on physical state is most of them are non-competing. So if you look at blockchain consensus, you have like if you're on the Ethereum ecosystem, you have to commit to Ethereum proof of stake. If you're in the Solana, you have to commit to that. It's like a religion, right? But in physical consensus, physical attributes come in various flavors: location, bandwidth. There can be storage, compute, energy, so on. And the whole system has what we call pluggable consensus, which is you can deploy, once the system is ready, you can deploy different modules. So over here, I've listed a few modules here that we'll be deploying. A few of them we already deployed. And people can add to it in the future. Now, the watchtowers, eigenlayer operators, choose which of these systems they want to be part of. And in doing so, they can they indirectly choose like what DePINs they want to validate. In the normal path, it makes sense for them. Since these containers are so lightweight, they would validate all of these attributes.
So which services are going to be rolling out first, and in what order, and like why were those decisions made, I guess?
Perfect. So let me. Okay, yeah, I think since your community would already know, we went live almost a month ago, and thanks to the economic power sitting behind eigenlayer, we already have 6 billion in restaked ETH, and we're supported by more than 65 operators at this point. The roadmap looks like this. So we didn't go into the details of like the different proofs here, but what we think is fundamental to secure before we secure the physical state is to secure the digital state itself. Securing, and the leading ledger in the current space are rollups, right? So a lot of DePINs get deployed on rollups. There exists a lot of rollups out there. So what we deployed at the very first is a rollup watchtower network, which uses our proof of diligence, make sure that so rollup watchtower network is in some sense our OG DePIN in our space. It's a set of independent nodes which make sure that which watch a rollup and make sure that there is no fraud happening on the rollup stack. We deployed a testnet for this at the start of this year. We have deployed a mainnet for this in April 11th. What's coming next is we'll be releasing a testnet for the rest of the DePIN coordination layer, which is proof of location and proof of bandwidth, sometime around in June, with a mainnet coming in Q3. Around the same time, we'll be launching our Watchtower app, which will enhance the participation to a lot more entity because it's so lightweight.
Is the Watchtower app basically a way for someone just to run an operator or something?
It's an equivalent for that. It's a diversified operator. So there are operators which provide huge crypto economic security, and then we can use some operators just to provide the.
Okay, got it. Makes sense.
And then proof of in the future, like we have a lot more integrations. So a few of our DePIN partners are actually deploying deploying a version of proof of bandwidth, or they're completely new proofs on our platform itself. So that's what we call proof of X, which is our coordinated pluggable consensus, which will come live and somewhere in at the end of 2024. In the since we are on that topic,
The POX, as you said, proof of consensus.
POX is proof of anything.
Proof of anything. Oh, interesting. That's pretty wide open.
Yeah, it's a very pluggable system. So you can and the value here is you can coordinate. So if one team develops a proof of energy capacity, then that's something that can be used by multiple DePINs together. So there's a huge coordination advantage, not only at you can say it's a coordination advantage at an economic level itself.
Sure. And would these be like separate AVSs, or would this be like the same like one AVS? And
it would be part of the same AVS, but it's a free market deciding which operator choose to run which module. Yeah.
Gotcha.
In some sense, to give you an overview of what the current ecosystem looks like, it's we would like to think of ourselves as a bridge connecting the rest of blockchains with DePINs, right? And that's what we enable through these validated DePINs. So we have a lot of DePINs which will use the shared security layer. So in some sense, it's a shared security layer, but at a physical sense. Not only that, we have a few DePINs which, as I mentioned, would be deploying their proof of X on our platform. We call that coordinated consensus. And we'll be working on, we use ETH as a security, but we also secure other systems through a roll-up watchtower network. So DePINs deployed on any of this network will be compatible. And we've already seen a few applications developed on top of us itself, including a few fellow AVSs within the Eigenlayer ecosystem. Proof of location, I've been saying a lot about decentralization of blockchains and so on. But where decentralization is critical is when you have services that use compliance, or where you have something like multi-party compute, where you need independent parties, not just crypto economic security.
That's a really good point.
Parties. And silence is one example, and ethos is another example of compliance. We use the system. So it's not just DePINs, but this would be used by more systems as well down the road. Broadly, what we imagine the whole world is going to look like is, right now we see a lot of centralized infra. There are a few isolated DePINs out there. $30 billion, not a small economy, but compared to $3 trillion of what the whole of crypto is, it's really small. What we want to enable through this unified system is a much broader set of DePINs and applications built on top of them, and to bring out a whole new economy. I think that concludes our presentation. Thank you.
Awesome. I have a few questions. So how does the incentivization work for operators right now?
For sure. So incentives are since it's consensus on physical state, you can draw an analogy with consensus on digital state. So in blockchains, there's a fundamental incentive just to secure the blockchain itself. Those are your mining rewards. And then there is a transaction fee associated with securing a system. So we broadly follow the same model, where if the DePIN wants to get validated, the whole network wants to get validated, then you have a base consensus reward that comes from validating that DePIN. And then applications can utilize, so let's say there's an application where I am where I just want people to deploy this hardware and I get all the reward and they get a share of it, right? This application, I think it's a form of a standard forward, would require that application to validate whether this asset is actually performing the task that its delegator actually delegated it to. So that application built on top requires additional validation, and that's part of a transaction fee model that it will have to pay for performing that individual verification.
Gotcha. That sounds awesome. And like, how was your experience like building on top of EigenLayer, and like, what would be your advice to like people who are looking to build on EigenLayer?
It's been, like people sometimes underestimate the difficulty of setting up this whole decentralized network of validators. That's where a lot of economic value gets built, right? Even if you think of DePINs, they don't have this like validator set, and that kind of fundamentally contributes to a few blockers in that economy. So it's been like, because of EigenLayer, it's been made very easy for us to go and get that crypto economic security required to back this whole ecosystem. So it's been I would say a fairly smooth ride. A lot of the whole ethos around EigenLayer has been around coordination. So it's not just operators, like, fellow AVSs have also been very collaborative with us. So it's a great ride so far.
It's awesome. Yeah, that wraps my question, Nader.
Yeah, I guess a question to kind of follow up with Gajesh. You all have been involved in this ecosystem for a long time, and I'm just curious, like when you started building your AVS, and also now as you continue to maintain all of the like specific functionality that you all have written, like has it been hard to understand how to integrate the contracts with the service and implement any of the verification that's necessary to kind of like make this happen and abstract it away so it can be used, in a useful way? I mean, you kind of said that it's been pretty smooth, but I'm kind of thinking more specifically, like if someone was new and they wanted to build something, like what would be any guidance that you would give them in terms of like writing their actual code?
Definitely. So it's been, the way we have structured our engineering as far as smart contracts are concerned. Yeah, thanks, Matan. Is to have as broad of a view as possible. An example of this is, when we set up the operator keys, we separated the operator's key that was used for within EigenLayer slashing itself, and the key that was used for Watchtower network. Because in the future, those can be used for separate purposes. So the philosophy that we have followed is try to design your system as broadly as possible, because we know like EigenLayer is doing the same thing, and like eventually it will, you have great documentation, but all projects in crypto are continually evolving into the next phase, right? So having this mindset, the broader mindset, that make it as broad as possible, and then you can individually in the future update it to like exactly fit the framework, has been very helpful to us so far, especially in navigating some things which might not be finalized on EigenLayer side.
How many people work with you all on Witness Chain?
So we have a team of around 12 people.
We are
Cool.
really in two places. We are in Princeton, New Jersey, where we are both calling in from, and in Bangalore, India.
Got it. Yeah. When I was talking to you all before we started, you were mentioning Princeton. I thought that was kind of cool. I think like all of those Ivy League schools are kind of interesting to me because I've never really been exposed to much of that.
I mean, Princeton, we have a pretty active crypto culture for a like conservative Ivy League background. So in my classes are taken almost by crypto classes. 1 in 7 students in a class, undergrad class, take it, and so okay.
Very cool. Very cool. So we are kind of like out on time now, so I want to wrap it up by just asking if someone wanted to start building with Witness Chain, like what does that look like today? What will that look like 3 months from now? And what would be some of like the use cases for building out an actual product that might not exist today that could be built now with Witness Chain?
Sure. So I'll give the answer from the perspective of different communities. As an operator, please reach out to us. The documentation is out there. It's very lightweight to set up, to register with us and set up a Watchtower node. As an application developer, you can target two specific use cases. Right now, we have the Rollup Watchtower Network live. What Rollup Watchtower Network enables is you can build application using that leverages security of each individual transaction. So you can ask the system and say whether, hey, is this transaction confirmed or not? That provides what we call programmable security, and that opens up a lot of new applications to be built on top. On the DePIN side, once you have validated assets, if you're an application developer, you can. This is something that will come live in by the end of Q2. You can develop applications on top of physical assets. You can develop something like DePIN, DeFi. It opens up a whole new area of applications that can be built on top. In fact, we have a hackathon coming on the same ideas, co-organized with DoraHacks. And as that's the second community, the application developers. And as a DePIN, you can register with us. Through this, you get exposure to the whole EigenLayer pre-staking ecosystem. And we have a new proof of X protocol. Yeah, you can integrate with us. So
that's awesome. I have one last question before we wrap up. So Sriram talks about this a lot, where if you have an idea, you can just build it, and EigenLayer provides the crypto economic security and computational power. I would love to know how was your experience going from academia to building a company, and what advice would you give to other academics who have a great idea but just looking to get these two things?
Sure. So when we started, one thing is don't underestimate the value of community, and that's what I would have said. I would have said that, hey, it will be very difficult to set up your operator network even if you have great tech. But now the advice is a bit different. If you go with EigenLayer, then it's very easy to set up your community and the operator network with great tech. But yeah, broadly, it's put very high value to as much high value to community as you put to the tech itself.
All right. Well, thanks everybody for jumping on today and spending time here to talk about Witness Chain. And everyone watching, thanks for stopping by as well. We're going to be back next week with Brevis, and we're also going to be hopefully launching all of the episodes on YouTube by the end of the week. So keep an eye out for that. And yeah, that'll be it. So thanks everyone again for coming on, and we'll see you next time.